Hello everyone. We are going to get into our next video. So we've got one more day. I'm going to finish up this stuff in 4.2. Okay, remember 4.2 is all about this point slope form that we started the other day. And we are on page, where are we? We're on page 105 here in our student journal. Okay, pretty short notes today, not too long of an assignment today. We are going to finish up 4.2 today. We're going to start on 4.3 tomorrow, finish that up this week. And then that short week next week, just that 2-day week, we're going to take a quiz that'll be all of chapter 4. We're just doing these 3 sections of chapter 4. It's really short. Right, so you can wrap up before Christmas break. We don't have to worry about anything afterwards, or at least continuing on with the same chapter afterwards, and we'll start chapter 5 when we get back. Alrighty, so let's go ahead and get started. I really just want to do a couple of these problems here with this function notation. I'm not really going to bother with this stuff in the table and that word problem. I don't like this example because there's not really a similar problem in the homework. So we're just going to work with these function problems. This is similar to what we did with 4.1. We had some similar things where we had 2 points, but they were given to us in function notation. So we're going to approach this in a similar way. All right, the instructions are telling us, okay, write a linear function f with the given values. And the way that functions work, remember, function means it's in function notation, that f of x is equal to something, which we know that f of x is the same thing really as y. So that's the same thing as saying, okay, cool, well, y is equal to something, which I'm saying just to remind you that if we have a function, that means it has to be in this like y equals something format. It can't be like x plus y on one side and then other stuff. I'm saying we have to isolate that y on one side in order to turn it into a function. You can't just turn any equation into a function. You have to isolate the y first, then you can swap it out with that f of x. Okay? So let's go through this whole process. So essentially what I'm saying is we have to turn this into slope-intercept form. Okay, this has to be in that y equals mx plus b, not in just point slope form. Okay, so let's break this problem down a little bit. We've got all this stuff. Remember, this is just like in 4.1 where it's all in that function notation. So it's saying, okay, I've got f of -3 is equal to -1. Okay, whatever is inside your parentheses, okay, f of x, okay, whatever's inside your parentheses, that's your input. And it's saying when I input that -3, my output is -1, that's my y. So my first point here is -3, -1. Okay, I always have my points in that x, then y. Okay, and then here, my second point, when I plug in -2, my output is 4. So my second point is -2, 4. All right, makes it fairly easy. It's in the same order. You don't have to flip-flop them or anything. Then we want to think about, okay, with point slope form, because neither of these points are my y-intercept. I know I have to use point slope. With point slope form, I know, well, okay, I have points, but I need to find my slope. Okay, we've got that y2 minus y1 over x2 minus x1. So we're going to fill that in here with the information here from these 2 points. Okay, you don't have to think too hard about what's going to be my 1 point, what's going to be the 2 point. Remember, it doesn't matter as long as you stay consistent through the whole problem. So let's call this R1 and this R2. Okay, I'm just going to work all through underneath these other problems because it takes a little bit of work. All right, so, okay, y2 minus y1. Okay, so the y from our 2 point is 4 minus y1, so the y from our 1 point is -1. Okay, then x2 minus x1, so the x from our 2 point is -2 minus x1, so the x from our 1 point is -3. So let's rewrite that. That's 4 plus 1 and -2 plus 3. So that gets me 5 over 1. Shouldn't have to think for that long. Okay, 5 over 1 gives me 5. Okay, so my slope is 5. And now I can go ahead and plug it into point slope form, which is step 1 on getting it into slope intercept form. Okay, so let's remember from the other day my point slope form. This is something I would make sure I highlight in my notes. I knew exactly where it was, okay? Because a lot of people find this hard to memorize. It's that y minus y1 is equal to m parentheses x minus x1. Okay? Some people find that hard to memorize, so make sure you have it handy in your notes when we take that quiz. Like I said, right before we go for Christmas break, you can find that easily. You're not searching around all in your notes to find that. Okay, so remember, you leave the y, okay, you leave the x. What you are plugging into is this y1 and the x1. That's where the actual point gets plugged in. You plug in the m, you plug in, okay, the x1 and the y1. Okay, you have this point x1, y1. That's what gets plugged in. So usually the way I choose which point that I'm going to plug in, I pick whatever one has less negative numbers, because that just makes it annoying because you're subtracting. It really doesn't matter. Again, any point on the line will work if you plug it in. Okay, so y stays the same, minus y1, so the y in this point is 4, is equal to m, which was 5. X stays the same, minus x1, so over here the x in this point is -2, so minus a -2 is going to be +2. And then again, I can't just say, okay, here is my function. In order to call it a function, I've got to have y isolated. I've got to have it in this slope-intercept form. So let's go ahead. I know the first step to simplify this, I have to distribute out this 5. All right, so I get y minus 4 is equal to 5x. Okay, 5 times x is 5x. And then 5 times 2 is 10. And then I'm going to add 4 here to both sides. Okay, I want to get y on its own, so I'm going to cancel out that -4. So I'm going to get y is equal to 5x plus 14. All right, but again, if you mark this on your test, I at most might take off 1 point, might not take off any, I guess, depending on how nice I'm feeling. If it asks for a function, you shouldn't leave a y. You should go ahead and replace it with that f of x, right? It means the same thing. You'd graph it the same way, but if it's specifically asking for a function, you want to put it in function notation. Remember, all that means, take out the y. So like over here in the slope-intercept form, take out the y and replace it, okay, with f of x. Okay. So go ahead, really all I have